Welcome to the Teaching Science Podcast.
These episodes are recorded on Mondays at 4 p.m. Eastern in our virtual Teachers Lounge.
If you would like to join us on a Monday to chat about a topic related to science education, go to the calendar in our show description to get the link for the week.
You can listen to the recorded discussions as a podcast from any major podcast provider or on the Superheroes of Science YouTube channel. Start with Dan. Let's throw you under the bus a little bit. As a scientist, chatting with us educators and people, feel free to if you have questions and stuff, jump in. That's why he's here. He's really good about answering questions, and if he doesn't know, he's not going to make it up. He's not that type of guy. Otherwise, we wouldn't have asked him to come chat with us. But we use more and more coding. A lot of times, we're using microprocessors like Raspberry Pi or Arduino. And I kind of thought when I started trying to figure out how to teach with these, I thought, well, this is just something that we're just using to teach the kids, but it's not something real that people actually use in science. And so hence comes our scientist to tell me if that was a misconception that I derived on my own, or is this really something you wouldn't use as a scientist?
Well, first off, Stephen, thank you to you and Sarah for having me back on. Hopefully I didn't do anything too bad on Superheroes of Science, so I did get another invite to work with you guys. Yeah, I have to just tell the funny story. So when Stephen and Sarah wrote me and asked about coding, I was like, I'm not a coder. I don't do atmospheric modeling. I build instruments and we put them on research aircraft. We put them on mountaintops to do measurements. And I'm like, I can't possibly be the right person to help you out. And then Stephen and Sarah sort of explained to me, no. You were telling us about what you do on the aircraft and how you build these instruments and what you look for in members of the group. And it took me a minute. I'm a little slow, and I finally got it. And I was like, okay, I understand now. And so yeah, the background is that my group and I do atmospheric measurements. We often get blamed for bad weather like this, but we're actually the ones that go out in the snowstorms. We do things like collect snowflakes and we break them open and try to see what's in the middle, what they formed on. And to do that, we build instruments, mass spectrometers and things like that. We're building one right now that's going to go on a NASA research aircraft. And so this is their ER2. It's what people used to call the U-2 spy plane. And as Stephen pointed out, there's a lot of little components on that. And so to run those things, we need a variety of different equipment that we do. And so it isn't as simple as just like one large computer. We have small parts, small servos, valves that open, things like that. And so we do have a large computer. We run that off of a program that we call National Instruments LabVIEW. That's very common for instrument use. But we do use a set of small Raspberry Pis, small Arduinos, things like that to run these small servos, small motors. And so it is one of these funny things that we often find ourselves in hobby shops. We often find ourselves working with students that have grown up with these things, with drones, working with small model aircraft, things like that. And they think that what we're doing is at such a higher scale. And we're like, no, we use exactly the same parts. And so Stephen, correct me if I'm wrong, but I think one of the things you wanted to hear about was the fact that we actually do go out, we pursue students that have that experience. And so very often, we're going to groups or we're asking groups, do you have experience in this area? And that's how they get a start in our group. And then we find that we can easily train somebody that has that base experience on something like LabVIEW to run a large mass spec. But training them from zero is nearly impossible. So we really are looking for students with that background. Stephen, is that really kind of where you wanted me to jump off with this? Is that helpful?
Yes. It was just like I said, I was amazed when you're like, oh no, we actually use these things. I thought they were just for education. I didn't know it was like real.
Yeah, no, we continue to use them. They're incredibly helpful. And maybe one other thing, Stephen, you and Sarah, that I've talked about is, we fabricate a lot of our own components, and they're not just metal anymore. A lot of them are fabricated with 3D printing, and 3D printing is one of these things that, again, we see it being used in hobby shops, home use. People that are building drones are using 3D printing. So the one that we have is from a company called Formlabs. We were just talking about Cambridge, so it was founded by some MIT students, and it's in Cambridge, Massachusetts. It's about $5,000. And so it's something that, a lot of high schools can find affordable. They use them in high school hobby shops. We've got a set here at MIT. We had a set when I was at MIT. We've got another set here at Purdue. And Department of Chemistry has them, engineering has them, our group has them. So you can see that they're very accessible. The software, the coding for them is something that a lot of students are learning now in high school.
That's just amazes me. It blows me away because these are things that we were teaching in high schools everywhere. Well, I say everywhere, but a lot of places are teaching aspects of this in high schools. And I know we kind of wanted to panic a little bit when we found out we were going to have to start doing coding, especially like the middle school teachers and the elementary. And we'll go in a couple weeks of what they're expecting at different grade levels when the Indiana Department of Education's here talking to us. But this week, I just think I really wanted to hear actually from a scientist to know are they actually using these things, and if so, how? But the fact that you said you're also looking for students with experience with this, I think speaks volumes. And the things that we teach our students that is actually applicable once they leave our K-12 realm.
When you're looking for students that have experience, what kinds of experience are you looking for that they have?
Yeah, it's a great question. So a lot of times, when we're doing an informal interview, and a lot of times we do it just like this, we'll have a Zoom chat or a WebEx chat. We ask them about their hands-on experience because that's, I think, the critical thing to find out if they're going to be successful in an experimental setting or not. Students that have worked on something at home, whether it be those drone projects or they've, we had a student that I'm just remembering that told us that they took a class online to learn how to build a radar. And when you hear stuff like that, you're just like, oh, that's who we want to work with. So yeah, the key is just hands-on experience. And by hands-on, that can be actual physical parts. It can also be, coding in general that they've developed something. It can be a game, whatever it is. And we just like to see that experience. Because if they're book smart, that's great. And very often we can train them, but we know that they're going to have a leg up if they've done anything hands-on.
That's awesome. That's awesome. Did anyone else have any questions for Dan? If you have trouble saying it, you can type it in the chat. By the way, everything's open on. I don't want to keep him for a long time, but I want to make sure if anyone has questions on that as an educator towards him. Like I said, he does a good job answering.
Well, thank you. It's because I've worked with good interviewers, you and Sarah. It's been great. I mean, I could be really selfish here and just say, we're always looking for students in our department. We're a very hands-on department. We send students out in the field. Could be to pick up rocks, could be to collect snowflakes like today. So, please send students our way. We love seeing students get, referred to this department.
And so
That's awesome.
That is awesome. And I see a couple of names on here I know are kindergarten teachers.
Honestly, they don't have to be college ready. We've brought students in high school. Stephen, Sarah, you've probably heard of some of the programs, but summer interns, things like that. We are always happy to host students like that.
I'm a little curious about snowflakes because what I'm thinking is Krista and Amy they're probably going to be teaching snowflakes this week, being that the entire Midwest is under snow. And so, but you're breaking snowflakes.
Oh yeah, do you want to hear a little about that? It's off the subject of coding, but
yeah, but I'm really curious.
Oh, good. Okay, so everybody, if you go outside and you see a snowflake, it's a hexagon, right? So it's got 6 sides, and it could be like a hexagon, or it could be a dendrite where it's got the 6 arms on it. But it's always looks symmetric around a center point, right? Well, it turns out there's always a small special particle in the middle of it. We call it an ice nuclei. But that's where the ice formation started. And something on that particle was very good at forming ice. And so it starts at that point and then it moves outwards from there. And so your dendrite, if you look at the very center, has a little ice nucleating particle. And so that's one of the things that we study because we want to know if they're changing in the atmosphere as humans influence the atmosphere. Are we making more of them or are we affecting them? And so, yeah, Stephen, one of the ways that we've actually historically done it is you collect those snowflakes, you crack them open, you go right for the center and you figure out what that particle is and you can actually pull it out and do analysis on it. And so, spoiler alert, a lot of times they're mineral dust particles. They're bits of dirt, bits of crustal material. And so as the planet becomes drier with climate change, certain areas like the Southwest, and it sounds like we have somebody here from New Mexico, so more frequent dust storms, more of these ice nucleating particles. And so we see clouds tending to change, and you can have more ice crystals as a result. Yeah, so go outside. Every time you see a snowflake, crack it open and see if you can find, no, I'm kidding. You need a pretty good microscope to pull that off.
So I have a question. So you are Dan, right? Sorry, I didn't check your name. Is it possible you can share some of your pictures of the ice crystal with us? We have been running a study group on rocks plus Python. So we do some image processing with Python and with some rocks pictures, because we have rocks in Southern Nevada everywhere. But I think the ice crystals are very interesting. Do you have the images online so we can check out?
I do. You know, there's a really great site at Caltech. Let me
I
see
know
if I can
that one.
find it, and then I can post it in the chat. Do you know the one?
We know the one.
Yeah. So the two best libraries are the I think it's the Ken Librick's lab does that at Caltech, and they've got a really nice interactive website for that. And then the other one is at the University of Vermont, and that's actually where a lot of the ice crystal research started. And when I say started, I'm back in the 1800s. Nothing that we have is better than those two. So I would highly recommend those two as being the best sites.
If you don't mind, I have another question, because we have an earth scientist here.
Please, yeah.
So we have been trying a project named, we titled it Rocks plus AI. So we are thinking about, we collect as many as possible rock images, and then we want to develop an algorithm to classify these rocks, just major types like sandstone, basalt, granite, just maybe a couple of, maybe 7 or 8 types. Do you think that's possible?
Oh,
just based on the rock images.
Yeah. So Stephen mentioned earlier that I will not mislead you, and I will tell you if I don't know something. So image recognition, I believe what you're talking about is possible. Stephen, Sarah, having somebody like Marissa Tremblay on would be great, because I think she's studied some of this, what the broad features are of the rocks, and could you pull those out with image recognition and be able to do a classification? I think I don't see any reason why you couldn't do that. It's the type of thing that we do in the atmosphere with particles, ice crystals, droplets, differentiation. But I'm afraid I'm not sort of a solid earth geologist. So one of our colleagues like Marissa would probably be able to answer that question better than I could.
I didn't think about Marissa. I like that. Ping, we'll send her an email. We'll send her an email this week.
And about the Arduino, we have some schools in Southern Nevada. They have been doing Arduino. I think they will contact you in March. They are going to finish one project. One middle school and 2 high schools in Southern Nevada.
And are they going to do the student competition that we're having on May 30th and April 30th and May 1st?
I sent out your emails to them, and they all know about the competition, but I'm not sure they are going to, maybe, because they are going to finish their project next month. So I think it's a good opportunity for them to show off their project, right?
Yeah, it'd be a great one.
Perfect timing.
That'd be a really good thing for them, since they're figuring things out and doing coding, and they can also apply to get a free kit, a student kit, each of them. That's on the what webpage, Sarah?
It's on the Geostem
Okay, the Geostation conference webpage.
Page that we just pushed out. So yeah, there's a link. Yep.
So let your kids know they can get Arduino kit if they fill out a form and they're doing some research with coding, because we wrote a grant with Halliburton and that was in the grant. So we'll be sending those out nationwide to students that ask for those.
Oh, that's great.
Just
I
for the
think we have
record.
to start students as young as possible with this technology. It's great. So maybe kindergarten's a little early, but as young as possible.
Well, for the technology it is, but when Jake comes, I think he's going to talk about computational thinking a little bit and talk about the fact that we're really teaching coding all the way down at the lowest level. Basically, I mean, think about our if-then statements for math, right? And so I know that when Mindy Hart, when we used to have a computer outreach coordinator years ago, and well, it wasn't that many years ago, a couple. She did a really neat with the hula hoop, and it was like, the kids were a robot, and she was programming them. And our students do a similar version of that at the Children's Museum during Passport Days that our department hosts. But kind of like the kids are the robots, and so you can only do what you're told type of thing. Simple as following directions activities, all of that leads them into computational thinking and understanding more about computer science. It's just a building block of understanding coding. And so you don't think about the fact that when you're teaching kids to follow directions and or even to say directions. And I love it. It's like the smaller ones when you're teaching them to build something, then you have to tell someone how to build it and things like that. You're teaching computational thinking also. That's a part of that. And so it's a building block to get to the point so they understand actually coding even. Well, Dan, if someone throws any at us, I might send you an email or something, or holler at you in one of our staff meetings later in the week.
Sounds
If
perfect.
there's any other questions, but thank you for your time. We appreciate it.
Stephen, Sarah, thank you again. And yeah, you're very welcome. And it was a pleasure talking to everybody. And I'm sorry to hijack it with ice nucleation talk today, but it is snowy, so it's probably a good day. Take care, everyone.
Thank you
Bye.
again. So what's everyone else teaching right now? I would say let's do a little lounge talk. What's everyone teaching right now in science?
No, we are just working with, we have a study group and we are working with students identifying rocks. So we have a rock picture and we want to know what this rock is, a sandstone. And then we use Python to do something to convert, doing creating a histogram of that picture. But for coding, we do math, not science, like Fibonacci sequence or prime numbers. Like we use Python, sometimes JavaScript.
And you're working with both high school and middle school?
Yes.
Okay. What
Because
about my elementary teachers? What do you all think? I don't know. I'm gonna say there's a couple people I don't know.
Our youngest student is only 6.
Oh wow.
Because of the Fibonacci number, it's just natural numbers, right? So little kids love that Fibonacci series.
You're talking Sarah's world. It's math. It's
because
like, did I see that on like National Treasure or something like that? I don't. Was there a movie about it?
Because I am myself, I'm a math major, so I always.
Oh, that makes sense then.
Okay, so I'm teaching snow this week. If we have school, because we're already down to a 3-day week. We don't have school tomorrow. So if we have school, we'll learn about snow and we talk about how there's a hexagon in the middle and then 6 branches that come off the side. And so then the kids get to build their own snowflakes. We'll go out and catch snowflakes on frozen paper, look at them up close with magnifying glasses.
Oh, you're doing it on paper? On paper?
We do it on paper. I just keep it in the freezer all winter long. And as soon as we need it, I pull it out and we run outside.
Like regular paper or black construction paper or what?
Black construction paper.
Okay. I was getting ready to go put a ream of paper in the freezer.
No. Don't put anything past me though. You'll never know what I'll do. And what else are we going to do? We're reading a book about snow. We're talking about where we usually see snow, versus warmer climates, where there might be snow other than here right now. And the kids are going to have their opportunities to make their own snowflakes, whether that be with pattern blocks or Q-tips or pipe cleaners, whatever method they want to use to show their understanding that there's at least a hexagon in the middle.
Awesome. And make sure now we got to put something in the middle so they know about that nuclei in the middle, since Dan talked about it.
I'm going to have to work on that.
That's something, honestly, I've never done for the elementary. I talk about cloud nuclei and stuff when we talk about clouds forming, but I've never thought about the snowflake also has nuclei, and to make sure I put something in there to let them know. I don't know. I hadn't thought about that before. I like it though.
Yeah, I really like that Dan mentioned that. That's a good point. I think, when you're talking, you think you talk about it with raindrops forming, but for snow too, that makes sense.
Now see, Jessica, she's
I saw in the chat.
Yeah, so she's going to plate tectonics. Wow, taking it up for our 8th grade. Did you just, all right, I mean, it's a cheap and low pitch, but I gotta throw it at you. Did you watch or have your students watch Bob Nowak's podcast from the Superheroes of Science? Jessica, he does a really good job talking about plates, and actually one of the research projects he does is listening to plates or earthquakes. I mean, listening to earthquakes. I thought that was kind of cool. And with what you're doing next, Jessica, give me a heads up, because I'm the Earth Atmospheric Planetary Sciences. Don't ask me anything about planetary. But I'm the Poindexter's laughing, her and Amy, because they remember we used to be Earth Atmospheric Sciences. I'd have Earth Science teachers like, oh, tell me, that I need help in my astronomy unit. I'm like, hey, I'm Earth and atmosphere. It's outside the atmosphere. It's not my problem. Then I show up at Hasty after we change our name to Earth Atmospheric and Planetary, and these teachers are like, it's your problem now. Like, I hate you all. But what if you're doing something next? Did you join the Sarah? What's it called?
Yeah, so we have our virtual group on Facebook. Is that what you're talking about?
Yeah.
Joining the group, yeah. If you're interested, we'd be happy to invite you to join that group, and you could put a request like that out, and that's another way that we could help you with resources. But yeah, also we'll get you that link as well. Oh yeah, Stephen just included that link to Bob's episode, and that's really cool, and you can watch it. And I think in the video description they have links to a lot of resources to the things that Bob talks about. But I was really shocked. I didn't know that. It makes sense, but I didn't know you could listen to an earthquake, to the sound it makes. And he goes through several of those where you can listen to it. It's a pretty cool thing.
But if you're doing something else,
good job.
Like the next thing you're doing, especially if you're a new teacher, Jessica, it's literally my job is to help teachers teach science. This is all I do. The crazy projects we come up with, like that STEM workshop that we just posted, say Ping helped us with that, thank you, and stuff that was just because people asked for that, and so we put things together based on what people asked for. And so I know now that big project's done, Sarah and I are both working on the elementary school, the kids STEM degree that we'll do. They'll get a little degree from Purdue, certificate saying they got a degree in STEM by going through different activities that we're putting together. We have some students, some grad students, some undergrads have done some of them, and then Sarah and I are doing a bunch of them. But we're really, every week we want to have a one of these little virtual sessions. And so if someone's thinking of what you're getting ready to teach or what you just taught and works well, and kind of throw it out to the group, that's why we want to have these live sessions so we can kind of interact. But then of course the Facebook reminder and stuff, or sorry, I'm reading and talking at the same time. The Facebook group is something for those anytime. You want, I'm gonna try to just put different activities and different things that we have on there. Gonna say the cloud in the bottle activity was mine back when I had hair. No comments, Poindexter. But I expected to see Mike on there commenting on that or something as soon as that went up. Yeah. But so as if we have those, we'll release those and on that group. Oh, there's Amy. Coordinated science content with writing, or observing and describing objects. That's perfect. And it like I said before, it falls into understanding it, because I mean, our son took Polytech for cybersecurity, and in order to take the Polytechnic classes, you have to take a test. Oh, that's a scary guy right there. You have to take a test that, like, if you see an object, then you have to say which one is the object in different orientations. And so that's once again, that's foundations, observing and describing objects. Foundations for things way down the road that we won't even think about them going to. Did Mike cut his beard? Did he trim his beard?
I love having them observe and write about that. That's so great for kindergartners. I think that's a great thing to have them working on now. It's really, really appropriate, especially for kind of like when we talked about some things you don't even realize you're doing the science. Oh, and Jean is doing it too. Great. And sometimes you don't even realize you're doing the computer programming when you're learning like directions and things. And I think that's kind of similar when you're having them describe the objects that they see. That's a really key piece for for science observation. So that's awesome.
I'll see. And I thought Gina just logged in and walked away. I didn't think she was really there. God, we didn't say anything about her. It's we were dominated by some of the lower grades here, it sounds like, today. But we will get, now that we have to, since there's so many kindergarten teachers here, or primary teachers, that I guess we're going to have to get that the Purdue STEM degree up. And that's just going to be really short videos for kids with like little experiments and stuff like that. And we're going to, now that the conference stuff's all out there and open for teachers, and we're hopefully going to get good feedback on that soon. But we're going to switch over and get the STEM degree done, so we have it up and posted this semester. We're excited about that. Well, we're over our time. I said we'd go to 4 to 4:30, and I apologize for going a little over. It's not like a real meeting, though. So, a real meeting, I'm a stickler. But this is just like we're all chatting. But as you guys on the Facebook group, throw out your questions and stuff. And if you're going to do a unit, like Jessica, if you're going to do a unit here, you're finishing up plate tectonics, you're going to do the next thing, you want ideas and stuff, throw that out there. And say, I'm sure if we don't have some, other people will. And if other people don't, then I guess I know that we need to work on finding you some. And we will. We're pretty good at making stuff up. I mean, finding stuff. But boy, just shakes her head as she works on her crafts. All right, I'll log this one off, and like I said, we're going to be here hopefully every week.
Thanks for hanging out with us in our virtual lounge.
Please like, download, and subscribe, and share the love.
Oh, I was going to say share the love.
Find us on Facebook, Twitter,
YouTube,
and follow us everywhere.
Just not in a creeper way.